Okay, let's pick up where we have left off. We had just left off in class that the cosine of 135 degrees with the inverse cosine on the front wound up being 135 degrees. And that was because this 135 is in the interval 0 to 180 degrees, which we found in our domain and range. Okay. For our inverse cosine, remember 0 to 180 is the same thing as 0 to pi. Yeah. And then here on part C, for our arctangent, remember that that is the inverse tangent of negative 30 degrees. Remember, inverse tangent needs to be from negative pi over 2 to pi over 2. And remember that that is equal to negative 90 degrees, 90 degrees. And because it is in between the two of those, looking at the top blue box on the top of the page, we can say that this is equal to negative 30 degrees. Because remember at the top in the blue box, it says that if you're taking an inverse tangent of tangent, it will equal whatever's on the inside if this part holds true. Just like the inverse cosine of cosine will be x if x is in that interval. Yeah. I'm going to add in part D here so you can see what happens when it's not in the interval. So let's say that we need the arc sine of sine of 150 degrees. By that little blue table, if we're taking the arc sine or inverse sine of sine, it needed to be in negative 90 to 90. And that was with our degrees. So when this happens, this means it's not going to be in the domain of the arc sine. We're going to find the reference angle for 150 degrees. Okay, so here, 150 degrees, we know is over here because it's not quite 180, which means that our reference angle is going to be 30 degrees because 180 minus 150 gets us 30 degrees. So our reference angle is 30 degrees. So if we rewrite this as, or the entire problem as the arc sine of sine of 30 degrees, that gets us 30 degrees because it's in the reference angle. And this is legal because here, this 30 degrees is in the interval of negative 90 to 90. In example number 9, you can use your calculator to double check it, but you can also use the upper box if you want, where it gives us, for instance, sine inverse of sine is x if whatever the x is in between negative 1 and 1. So this guy is, and because it's in that domain, which I'm going to write in interval notation, because it's in negative 1 to 1, This means that the sine and inverse sine are going to cancel out, and we get negative 0.3. The 1.7 for the cosine arc cosine. If we're doing cosine and inverse cosine, this needs to be in negative 1 to 1, but it's not, which is going to allow us to say D and E. The expression is undefined. And in our last one, tangent, inverse tangent. By the top blue box, this guy, the x, needed to be in our interval of negative infinity to infinity. And because that is the case, the tangent, inverse tangent cancel out, and we get 5.4. Let's look at example number 10. Because we are wanting exact answers when we're evaluating the expression, let's go ahead and look at our angles. Sine of pi over 2. Remember, pi over 2 is at 90 degrees. Our ordered pair is 0, 1. So sine of pi over 2 is 1. This means we're looking at the problem as the inverse tangent of 1, because we plugged in for the sine of pi over 2. But remember, we can rewrite this. So if it's inverse tangent of 1, we're looking for where tangent of y is 1. But remember that our inverse tangent, its range needs to be in our interval of negative pi over 2 to pi over 2 because of the range of inverse tangent, because the y here was the range of the inverse tangent. Okay. So we need to figure out where tangent is 1. Sorry, technical issue. So we need to figure out where tangent is 1. We know tangent is 1 positive in the first quadrant. Right now we're looking at quadrant 4 and quadrant 1. So we can go here. If tangent is 1, that means we have 1 and 1 for our sides, which means that we have a 45, 45, 90, because it's 1, 1, root 2. So 45 degrees is hanging out on the inside. So tangent of y equal to 1 means that y is 45 degrees, but it says y needs to be in negative pi over 2 to pi over 2, which means we need to convert to our radians to get pi over 4. All right, part B. We need cosine of negative pi over 2. Remember, pi over 2 is down below. Our ordered pair there is 0, negative 1. And we know that cosine of negative pi over 2 is equal to 0. And since we're plugging in for cosine of pi over 2. This means that we have inverse sine of 0, because again, we're plugging in that 0 for cosine of negative pi over 2. So inverse sine of 0 gets us y, which means that we can rewrite this as sine of y equals 0, where y is in negative pi over 2 to pi over 2, and that is the range of inverse sine. Okay. So let's figure out where sine is 0 when we're working with quadrant 4 and quadrant 1. And so we're looking in these two quadrants, which means that sine is going to be 0 when y is 0, because our ordered pair right here, we have 1, 0. And then Axel would tell you that sine is y, value of our ordered pair. So we're looking for y equal to 0. Let's look at number 11. We're almost done, guys. Stick with me. We need the exact value of tangent of inverse cosine of 3 over 8. Let's tackle this inverse cosine of 3 over 8. Okay. If we set this up as inverse cosine equal to y, we can rewrite this equation saying that cosine of y is equal to 3 over 8. And y is in 0 to pi because the inverse cosine range is 0 to pi. Okay. All right. 0 to pi means that we are dealing with quadrant 1 and quadrant, not quadrant 4, quadrant 2. Okay, so quadrant 1, quadrant 2, and cosine is positive in quadrant 1. So we're going to be looking in Q1. So if we set up Q1 with our angle, remember that cosine is equal to adjacent over hypotenuse, which means that we have 8 on the hypotenuse. There's our angle. And 3 next to us. We have a right triangle. So we're going to be using the Pythagorean theorem to find the height. So 3 squared plus h squared. You could use a y if you want. I'm using an h for height. Is equal to 8 squared. So 9 plus h squared is equal to 64. H squared equals 55. So we know that h is equal to plus or minus the square root of 55. We're going to use positive 55, so the negative root 55, because here we are in quadrant 1, sine is positive. So we need h is equal to square root of 55. If we were in quadrant 3 or quadrant 4, we would have taken the negative root 55. But again, here positive because y value is positive. In quadrant 1. So now if I replace my h with the square root of 55, we can find the tangent of our angle. So our tangent of y, oh, I should have labeled it y, not theta. Quick change. There we go. Is equal to opposite over adjacent, which means that we are looking at square root of 55 all over the adjacent of 3. Next one, same type of thing, except they are giving us specifics on our restrictions. So we have the inverse tangent of b. I can rewrite this as tangent of y equals b. And remember, we need to look at the range of the inverse tangent, and the range of the inverse tangent is negative pi over 2 to pi over 2 in parentheses. Negative pi over 2 brings us back to quadrant 4, and positive pi over 2 brings us to quadrant 1. And here we have tangent is positive. So we're going to be working in quadrant 1. Our only choices were Q1 or Q4. We're working in Q1. So let's set it up. We said that we had tangent of y is equal to b. Any whole number can be written over 1. And remember that tangent is opposite over adjacent. So if we have our angle y, correctly labeled this time, opposite would be b, adjacent would be 1, and now we need to find our radius, our hypotenuse. C or R, you can name it whatever you want. I'm going to call mine C, which means that if we use the Pythagorean theorem, 1 squared plus b squared equals c squared. So 1 plus b squared equals c squared. Take the square root of both sides. We have plus or minus 1 plus b squared. Because c is our hypotenuse, we're going to want the positive square root. So I'm going to go ahead and label him 1 plus b squared under the square root. And now that we have our triangle labeled, we can find the secant of y. And remember that secant is the opposite of cosine, or the flip of the cosine. So we're going to have hypotenuse over adjacent. We just found our hypotenuse was the square root of 1 plus b squared all over our adjacent of 1, which means that we can simplify this down as the square root of 1 plus b squared. One more like this, and then we're going to do our application problem, and we will be done with 5-7. So we have the cotangent of the inverse sine, and they're saying that r needs to be greater than or equal to 5 because we need to plug in something that's between -1 and 1 into our inverse sign. So let's start with inside the parentheses like we have been. So 5 over r. I'm going to set that equal to y. Rewrite this. We would have sine of y equal to 5 over r, where y is in the interval -pi/2 to pi/2. And again, we're getting this from the range of inverse sine. All right, so these guys are familiar to us. We're working with quadrant 4, quadrant 1 again. Here, sine is positive. So sine positive, we're going to use quadrant 1. If sine was negative, we would use quadrant 4. And here, I'm looking at that 5 over r to determine that our sine is positive. If it was -5 over r, that's when we would be in Q4 because our sine would be negative. Set up our triangle for our reference angle. We have y on the inside. Remember that sine of 5 over r, sine is equal to opposite over hypotenuse. So I can label these as 5 for the height, r for the radius, and then we need to name or find the value at the bottom. Call it x if you want, call it a, whatever you want to do. But here I'm going to call it x. So we're going to have x squared plus 5 squared is equal to r squared. X squared plus 25 is r squared. Subtract the 25 from both sides because we're solving for r. When we take the square root, we're going to keep the positive because here x is going to be positive because we're in Q1. So what I did, we had the plus or minus, but we only need the positive here. If we were in quadrant 2 or quadrant 3, we would have taken the negative. Okay, so I'm going to relabel my triangle real quick. Technical issue. Give me a second. So the bottom is now the square root of r squared minus 25. And we are asked to find the cotangent of y. And remember, the cotangent is the flip of the tangent. So instead of instead of OA, we have AO, adjacent over opposite, which means that we have the square root of r squared minus 25 all over 5. And you know that we cannot simplify the 25 and the 5, which means that we have our final answer. All right, last one. We have a parasailer being pulled by a boat on a lake. So if we put our boat down here, yay, and we have him being, the cable is 218 feet long, parasailer is 176 feet above the surface of the water. So we have our guy being pulled behind us in our parachute. Don't judge. Okay, so he's got his parachute. We know that the cable is 218 feet long. And we know that our guy is 176 feet above the surface. They want to know what is the angle of elevation from the boat to the parasailer. So they're wanting to know this angle right there, angle of elevation. Okay. So let's set it up. We're looking at the opposite and the hypotenuse, which means that we're going to use sine. If we would have been given adjacent and hypotenuse, we would have used cosine. If we would have been given the two sides and not a hypotenuse, we would have used tangent. But here we can set it up. We have sine of theta is equal to 176 over 218. I'm not even going to simplify this. I'm just going to keep going forward. Here, I can rewrite this. To get theta by itself, I need to take the inverse sine of our fraction. And notice that it says the nearest hundredth of a degree. So when you are doing this in your calculator, make sure that you are in degrees, not radians. You should be getting 53.83679. And that 6 is enough to round us up. So we get 53.84 degrees.